for the last 6-7 lessons, we were looking at sets. Set builder notation, listing sets, intersection, union, and the last lesson we looked at how we can solve sets and find a numerical value and being assisted by Venn diagrams. Now we're building. We looked at what was in a set, we call the things in a set, and then we ended up with Venn diagrams. Now let's build one more layer on top of that. In this lesson, we're going to solve numerical problems involving 3 intersecting sets. Now if you look across here, you have an example of a Venn diagram with 3 intersecting sets. But before we get to that Venn diagram, there are a couple of things we need to understand. A couple of regions we need to figure out. And before we get there too, there's one little thing or little advice I want to give you. When you get into your mathematics classroom, the first thing you must tell yourself is, I can, I will master whatever I'm going to do. It all begins with the mind. So you have to set your mind for it. Okay? So let's get down. The first thing we're going to do is to identify some regions on this Venn diagram that I'm drawing that will help us to solve the others that we'll have. So here we have our universal set. We name our sets X, Y, and Z. So we have regions 1, 2, 3, 4. There we have completed X. 5, 6, 7. Are we finished identifying all the regions in the Venn diagram?
No.
Which region is missing?
X, Y, Z complement.
The union of X, union Y, union Z complement, and that would be out here. So we'll call that region 8. Now let's name the regions. Region 1 is here, and what we notice is that region 1 is a part of X, is a part of Y, and also is being shared by Z. So region 1 would be
X intersect Y intersect Z.
X intersect Y intersect Z. All 3. Here we have region 2, which is this whole thing here. And that would be
X intersect Y.
X intersect Y. But if I look again, I would see that X is part of here and Y is also part of here. So X intersect Y would be this whole thing. But if we just take out this piece and we have this region here, this upper portion here would be, this portion here would be what? Now let's go again. We want this whole thing here. You see this here? We noted it's X and then we have Y. So we say it's X intersect Y. But in X intersecting Y, we go to this little piece here. So we're taking out this piece. So what would you call this upper piece here now? Does this piece in here include anything from Z? No. So what would we name this region up here? This whole thing here would be X intersect Y. What do we name this piece up here? Is Z in here? And what do we attach to the set to say that Z has nothing to do with there?
X intersect Y complement.
No, that would be correct. There's a little word that we normally fill in there, only. So this little region here is X intersect Y only. But the entire thing here would be X intersect Y. So this piece here would be X intersect Y only. Good. Regions 1 plus regions 2 would be X intersect Y. The whole thing. Then we move to region 3. And region 3 would be, let us take the whole thing. This whole thing here would be X intersect X intersect Z. But then region 3, this portion is cut out here. So this piece becomes, okay. So we had 1, 2, 3, 4. X would be the entire loop. From the entire loop, we took out 1 piece, 2 pieces, 3 pieces. What remains in this region? What do we call it? Very good, David. Very good. So there we have X only. So what would we name 5? Y intersect Z only. 6 and 7 Z only. Now I want the 8th region. How do I write the 8th region in set form, naming the set? How do I write it? What shall I write it as?
X union Y union Z complement.
I have a brilliant group of students here. X union Y union Z complement. It's not in X nor Y nor Z, but it's still within the universal set. Okay? So we need to be careful when it's only or everything is included. Whether it's only or everything is included. And this little region in the middle here tells you that all the elements from here are shared in the 3 subsets. The elements in this region cannot be found in any one of these subsets here, but they're in the universal set. Now let us look at that example across there. And not because it's grade 9 maths means that we can't be ambitious. If we want our brains to develop to the maximum, we've got to push ourselves sometimes. Now look how simple this is. This question was taken from CXC 1996 paper, and it's question 3B. Now a Venn diagram is given, and we have our subsets A, B, and C, and the elements have been filled in. The universal set is represented by that symbol. And on the paper, this was figure 2 because it's B. In A, we have the elements A, B, D, E, and F. And remind you, you heard me say A. A is the entire loop. B has the elements E, F, G, H. C has the elements D, F, G, and H. So there you see C. And let's go down to the last one. So here we're substituting A union B union C complement. We would have U and V. Now let us see what the question is asking us. Figure 2 is a Venn diagram showing the universal set and 3 subsets A, B, and C. The lowercase letters written in the diagram are members of the various subsets. So here we have our lower cases. the first thing they ask us to do is list the members of the set A union B union C complement. Now that has been made very simple because before we got down to working that, we identify the different regions of this Venn diagram. So, Roman numeral 1, we write our set. The set would be A union B union C complement, and they ask us to list it. So if we're going to list, comes to your mind, what do we do when we list? First thing we know, we have to use what, Miracle? Curly brackets. And if there are more than one element, we also use commas. Good. So I'm going to ask Quincy to assist me in listing this set here. So I'm going to open my curly bracket. Yes, Quincy?
U.
U.
No, V.
And V. And we close. And you would have scored your first mark on that paper. Quite simple, isn't it? So you don't make a CXC question give you headache. Part 2. Second one. List the members of the set B intersect C. When you look again, you see only B intersect C. Now look here. We have X intersect Y only. But in this example, we have B and B intersect C. So we go to the diagram and we said, where can we find B intersect C? Where on the diagram does B and C share elements? So we have B, and here we have C. So B intersect C would be all in there. So if we're going to list the elements of the set B intersect C, we would have, yes, Damien, please assist me. F, G, and H. Thank you, Damien. Third piece. State the value of the number in B union C. Now, when we write it like this is saying they want, remember, a couple of lessons back, we did the cardinal number. How many elements are in this set? The union of B and C. So we find B. B would be all here. And then we want C also, everything in C. And we bring all this here. So we take everything in this region here. Everything in B and C. So that's B union C. How many, we don't want to list them now, we just want the amount. So, number of elements in B union C is equal to how many? Miracle, when you look there, how many elements you see in that region?
5.
Let's go. 1, 2, 3, 4, 5. So we come here, and we're not going to put D, E, F, G, H. We're just going to simply put a 5. Isn't that simple? Very simple. So that was our first example. Let us move on to our second example. And this one here is another CXC question. It was taken from the 1999 paper, and it's 3A. So we're given that the universal set contains the elements A, B, C, D, E, F, and G, where this symbol represents the universal set. L equals A, B, C, D, E, M, A, C, E, G, and N, B, E, F, G. Now in the first example, we were given a well-illustrated Venn diagram. Now we're given information, and one says draw a Venn diagram showing the sets, universal set, L, M, and N, and their elements. So let us clean this off. Now we know that we have to get a rectangle. That is going to be our universal, represent our universal set. So we put in our symbol up there. And before we draw in our three subsets L, M, and N, we examine the elements. Is there anything common in L, M, and N?
Yes, yes.
What is the common element? Is E the only common element?
Yes, yes.
Good. So because the three of them share an element, it means that would indicate to us that the three sets, when they're drawn here, they must overlap. And when you do that, you create a region for E. Come, Damien, put in E for me quickly. Where would E be? Thank you very much, Damien. But before that, we should have named our sets L, M, and N. Now let's go again. So we're going to strike off our E, because E has already been taken care of. Let us go again. Let us look at L and M. Are there anything in common?
Yes,
What are there?
yes. A and C.
A and C. Are A and C in N? No. So if A and C are in L and M but not N, they can't come below here. So we fill in our A and our C. Let's go again. Let us see if there is anything common in L and N. Vidali, is there anything common?
Yes.
What is common?
B.
B. So we take out her B. And it's common between L and N. Come on, Miracle. Stick that in for me quickly. B. Thank you. Now when we go back to the set L, we notice that A, B, C, and E are already in L. So if I should go around there, I see A, C, E, and here we have B. But across there I can see L has how many elements? 5. 1, 2, 3, 4. So what element should be in L only?
D.
D. So there completes my subset L. But when I look at my universal set, which are the letters from A to G, I don't see them all reflected here. So we're going to have to keep on going. Let's go to M. M and N, do they share anything?
Yes, yes.
What letter do they share?
G.
G. Now I'm a little puzzled as to where I should put G. Who want to help me with that? Thank you, Damien. Damien walking like our old man. Thank you, Damien. So G is gone. Are there any remaining elements in M? Any remaining? So we have 4. 1, 2, 3, 4. Here we have our M. So it means that no element is in the set M only. Agree?
Yes, yes.
So it means that M only would be what type of set? An empty set. Good girl, Vileli. Good. Let's go to N now. How many elements are in N?
4.
How many do we have here?
3.
3. What is missing?
F.
And where would F be? What do we name the region? N only. So I have F there. Are we finished? Now let us check back. The universal set contains the elements A all the way to G, and none were missing. So let's go. A, B, C. Come on.
D, E, F, G.
So we have them all covered. So, are there any element in L union M union N complement? No. Good. So we're finished with the first one. So let's cross it off. Second one. List the members of, and we're listing. List the members of the set represented by L intersect M, and we take that set and union it with N. So first of all, we're going to find the set L union L intersect M. And when we intersect L and M, what do we get? Here we have L intersect M. And what do we get there? What are the elements? ACE. Somebody might say we have ACE. Good? Good. And according to this set there, we have B, E, F, and G. And we want the members of the set L intersect M. And we take this set and we're going to union it with N. Now N is equal to B, E, F, and G. So let's union the two sets. Here we would have, what would be the first element?
A,
Uh-huh.
B,
Yes.
C,
Mm-hmm.
E,
Mm-hmm.
F,
And
G.
G. Isn't that simple? Yeah, so I don't know why it's a big cry about this is difficult and that is difficult. We gotta start from our minds. Good. The third one. Write down the value of, we're not listing this time, we're looking for what number? The word begins with C. Cardinal number. Good, Miracle. So we want the number in L intersect M, union N, complement. So that means they want L intersect M, union N, which is what we did up there. But now they want the complement of this. They want the number in there. Now let's identify the region here. L intersect M, union N, would be this whole region here. Putting them all together. Good. How many elements? We want the number. How many elements are there? You can see them, right? So let's count.
1, 2, 3, 4, 5, 6.
And we put in our 6 here. And if you look over the years, you begin to notice patterns with these questions. And you practice and you begin to understand the questions as long as you understand the concepts. And then maths becomes as easy as ABC. Good. Any questions? Fidelli? Fidelli, any question? Puzzled?
Isn't the complement supposed to be L only?
Oh yes, you are correct. The complement would be everything outside of this. And what is out? This is the union. And what is outside of this? D. And D should be 1. Brilliant child. Excellent. Excellent. You didn't see that, Damien? Excellent. Good. This is the union here. What is outside of that? That's what the complement is telling us. Not in here, outside of it. And that's D alone we can see there. And that's only 1. Quincy, anything is puzzling you? Can we proceed?
Yes.
Good. Third example. But this one here is a little different, even though it's 3 intersecting sets. It's a little different in the way it's illustrated. So let's get rid of this. Again, this one was taken from CXC 2000, question 3A. The Venn diagram below shows the number of students doing mathematics, accounts, and French in a class of 50. So you see our M, our A, and our F, names of our subsets. Here we have our symbol for our universal set. We have drawn up, and all the regions are represented either by terms or constants. So we see an X term, an X, And these are all x terms. We have 1, 2, 3 constants. The first question asks us, write down an expression in terms of x for the number of students who do accounts. So, let's shade accounts. And they want an expression. So, part 1, the expression would be the first piece here, added to the second piece, added to the third piece would make up accounts. So we have, what's in the first piece? 2 plus x plus 3. And we can simplify it to? What can we simplify this to?
5x.
No, not 5x.
5 plus x.
Thank you, very good. 5 plus x. It can be 5x because we cannot add if it's not similar. Like we cannot add apple to a bat. Good? We add apples or we add bats. So we add the constants, 2 and 3, 5, and the x comes back. And that is our expression. Here we have our x term. Finish. There's nothing else we can do there. The second piece. Write an equation. The first one was an expression. Now they want an equation. So we must see what in it for it to be an equation. What is that key symbol?
Equal sign.
Equal sign. In terms of x to show the information on the Venn diagram. So when we look at our equation, we must see everything in here in addition to what? Very good, Quincy. I like that. That's smart. Good. So we know that 50 of them are in the class. And what makes up this 50? Help me build my equation.
2x
2x.
plus 2
Mm-hmm.
plus x
Yes.
plus
Plus 3.
Uh-huh.
plus x minus 1
Yes.
plus
Plus that.
Thank you, Damien. I can hear that. And do you think they just want us to make that equation and leave it like that? What was the purpose of making the equation?
to find the value of x.
To find the value of x. Go Quincy. Here, go Quincy. So let's simplify. 50 is equal to 2x added to an x added to an x. Remember, we're adding like terms. 2x added to an x added to an x give us how many x's?
4x.
4 x's. A 2 and a 3 would give us a
5.
5 take 1,
4.
a 4 added to 10,
14.
14. Now if our aim is to find the value of x, first we've got to move this constant and take it together with this one so we can simplify. So we're going to have 50 take 14 is equal to 4 x's. When we take 14 from 50, what are we left with? 36 is equal to 4x. Therefore, 36 divided by 4 is equal to x. What's the value of x? 9. 4 ones, 4 nines. X is equal to 9. This implies that x is equal to 9. Now, why did we find the value of x? Look at the third part. It says determine the number of students who do mathematics only. We want mathematics only. Miracle, come and shade the region mathematics only for me. Quickly. Use a different shading from the middle. Do you agree with him, Videli?
Yes.
You agree with him, Damien?
Yes.
Sure? Sure.
Yes.
Good. So here we have mathematics only. Now, if he had let the lines go across to 2, that would have been just a general mathematics. But we want only maths. So this portion here would be both mathematics and accounts. Good? Now, mathematics. So let's go to part 3. They want M only. And when we look in the region M only, what do we see?
2x.
2x. Do we have a value for x? What is it? 9. So we're going to substitute 2 multiplied by 9, and 2 9s are 18. So there are 18 students who study mathematics alone. 4th, determine the number of students who do French. Did they say French only? What did they say?
French.
So we want the entire loop, everything in here. So the first thing we're going to do is make an expression for French. So here we have 4. For French, it is, tell me what to write. 3. Take 1. So we have 3 added to what? 22? 9. And we take 1. And what would we have now? 11. America, you there with me? Damien, are you puzzled? Quincy, you're smiling. So you're there with me. So this is how we can use 3 intersecting subsets to find numerical values. And here we were looking at how we can use the cardinal number and how we can see intersection being played out, and how we can take one set, as in this case here, we take one set, union it with another, look at the complement, and then find the cardinal number. So we have lots of things that we did before. We took the ideas or the concepts and we put them together, and then we can look at sets that are intersecting, and there are 3 of them, and solve. Okay? And in as much as you might hear the word sets, you can apply sets to your home, of course to your schooling, whether you want to go to the workplace, because you can look at 3 different departments, see which worker is overlapping where. So set plays a critical role in you understanding maths and life out there. Okay? Now this is going to bring us to the conclusion of our grade 9 scheme on sets, and I hope that whatever we did would be a basis to launching you into the CXC examinations. And I know and I'm convinced that all of you would come out with distinction passes, right?
Lesson 14, Sets, Venn diagram. In this lesson, we will use Venn diagrams to solve numerical problems arising from the intersection of 3 sets. Here are some key points. Venn diagrams can be used to simplify word problems. We can form equations to solve problems involving Venn diagrams. If A intersect B, then number in A is not equal to number in A only. This Venn diagram can be used to investigate 3 qualities. The Roman numerals represent different regions. How many sets each region represents? Region 1. Set description: R intersect L intersect G. Region 2. R intersect L only. Region 3. The set R intersect the set G only. Region 4. The set R only. Region 5. The set L intersect G only. Region 6. L only. Region 7. The set G only. Region 8. The set R union L union G complement only. Let us study this Venn diagram. Universal set U is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The set A is equal to 0, 1, 2, 3, 4, 5, 6. The set A only is equal to 3 and 6. The set A intersect B is equal to 0, 4, 5. The set A intersect B only is equal to 4. The set A intersect B intersect C is equal to 0 and 5. Instead of naming the elements in a Venn diagram, it is sometimes more useful to say how many elements there are in each region. The number of elements in the set X is equal to 8 plus 2 plus 9 plus 1 equals 20. The number of elements in the set X only is equal to 8. The number of elements in the set X intersect Y is equal to 2 plus 9 equals 11. The number of elements in X intersect Y only is equal to 2. The number of elements in X intersect Y intersect Z is equal to 9. The number of elements in Z only is equal to... Example 1. In a group of 43 students, 18 play the recorder, 19 play the violin, and 16 play the piano. 6 play the recorder only, 9 play the violin only, 5 play the recorder and violin only, and 2 play the violin and piano only. 7 play none of the instruments. A. How many students play all 3 instruments? B. How many students play the piano and the recorder? C. How many students play the piano only? Solution. To find the number of elements in the set R intersect V intersect P equal X. The subset V has only one unknown, but number in V is equal to 19. Therefore, X plus 5 plus 9 plus 2 equals 19. X is equal to 19 take 16 equals 3. B. To find the number of elements in R intersect P only, which is equal to Y, the subset Y now has only one unknown, but number in set R is equal to 18. Therefore, Y plus 6 plus 5 plus 3 is equal to 18. Y is equal to 18 take 14 equal to 4. C. To find the number of elements in P only, which is equal to Z, the subset Z now has only one unknown, but number in P is equal to 16. Therefore, Z plus 4 plus 3 plus 2 equals 16. Z is equal to 16 take 9, which is equal to 7. The complete solution. Example 2. In a class of 32 children, 18 like tennis, 17 like swimming, and 15 like cricket. 8 like cricket, both tennis and swimming. 6 like both cricket and swimming, and 5 like all 3. A. How many students like tennis and cricket? B. How many students like tennis and swimming only? C. How many students like cricket and swimming only? Solution. Let T equals the set of students who like tennis, S the set of students who like swimming, and C the set of students who like cricket. Number in U equals 32. Number in T equals 18. Number in S equals 17. Number in C equals 15. Number in T intersect S intersect C equals 5. Number in T intersect C equals 8. Number in T intersect S equals 9. Number in S intersect C equals 6. Number in T intersect C only equals 8 take 5, which is equal to 3. Number in T intersect S only equals 9 take 5, which is equal to 4. Number in C intersect S only equals 6 take 5, which is equal to 1. The complete Venn diagram. Number in U equals 32. Number in T equals 18. Number in S equals 17. Number in C equals 15. Number in T intersect S intersect C equals 5. Number in T intersect C equals 8. Number in T intersect S equals 9. Number in S intersect C equals 6. Example 3. The number of elements in the set number in A intersect B intersect C is A 4, B 3, C 2, D 1. National Grade 9 Examinations 2006. Answer C 2. Summary. If A intersect B, then number in A is not equal to number in A only. Venn diagrams can be used to simplify word problems. We must consider number in A intersect B intersect C in finding number in A intersect B only. Problems for today. Mathematics for Secondary Schools in Guyana, Book 3, page 39, exercise 3E, questions 4 and 6. Solution for the problem given in the last lesson. Page 33, exercise 3D, questions 4. In a class of 33 girls, 18 study art, 10 study home economics, and 9 do not study either. Let X represent the number of girls who study both art and home economics. Form an equation in X and find the value of X. A equals the set of students who study art, H the set of students who study home economics. Let X equal A intersect H, the set of students taking both art and home economics. 9 do not study either A or H. Number in A union H complement equals 9. Number in A union H is equal to 33. Take 9 equals 24. Number in A is equal to 18. Number in H equals 10. Number in A union H equals number in A plus number in H, take number in A intersect H. Substituting, we have 24 is equal to 18 plus 10, take X. 24 is equal to 28, take X. Negative 4 is equal to negative X. X is equal to 4. Study both A and H. C. A, set of positive integers. B, set of even numbers. Positive integers that are even. D. A, set of prime numbers. B, set of numbers between 50 and 60. Set of prime numbers between 50 and 60. E, A, the set of factors of 30. B equals the set of factors of 80. 1, 2, 5, 10.
Quincy, you enjoyed it? Yeah. What's the best part of it, Quincy? Finding the cardinal number. And did you when you were in first and second form, were you exposed to cardinal number? Not really. But make sure you go tell somebody else about it, right? Damien, you want to share anything you enjoyed the most today? Substituting for X. And you see how algebra helps in sets here too? So everything you do builds and helps in understanding. Good?